Hi everyone, in this tutorial I will show you how I made this roof with geometry nodes system. It's not the most optimized geometry node tree, but it works pretty well for me and I think it looks very nice in this interior. So let's jump into a new blend file and I will show you how I made this roof with geometry nodes. Okay, so we'll start by deleting everything except our default cube. And we will transform our default cube from our roof structure. Let's jump into top view and scale it in Y and X axis. Okay, let's scale maybe in Z a little. And now I would like to create in edit mode two columns for our roof. So let's create some loops by pressing Ctrl R. And let's switch to face selection. Select these two faces and let's extrude it. And now I would like to scale it, but as you can see it is scaled at the median point. And I would like to individual origins. Okay, let's extrude it again and scale it a little bit. Okay, I think this is nice. And I would like to randomize the shape of the roof a little bit. So let's another loop cut. Switch to vertex selection and let's move some point in Z axis. Let's do it here too. We can even move this point like that maybe. Okay, and I think it's pretty good shape to start. And to better preview our final results, let's add modifier to it. Add subdivision surface. Let's increase the amount to 3 for now. And let's turn off shade out to smooth option. In my original file I have this flat roof and we can create it too by going to edit mode, selecting the faces that we would like to remain flat, and under N panel we have the option increase. We can increase it to 1 and as you can see now our roof remained flat. You can apply it the increase option to any edge, for example this one, and with any strength. Maybe you want a little less intense result. But I think this is pretty nice. Okay. Other thing you might want to add the crease is the bottom part of our column. If we set it to 1, we have nice flat columns. Okay, so I think this is our base geometry to start, and let's jump to geometry nodes tab and add new geometry node system, and let's call it maybe parametric wood. Okay, so before we start I would like to talk process a little bit. So we started by creating the base mesh and subdivide it. Then we create the base geometry for panels, which we will create the structure. It will match the size of our input geometry. Then we will scatter this panel to create the base geometry for Boolean. And after that we'll use Boolean to create the new geometry based on our input geometry. And at the end we'll add thickness to create the wood panels, assign the material and create the random seed value for each panel we will use this random seed to create a randomness across our wood material for the roof. So let's jump back to geometry nodes and start creating the structure. Okay, so let's start by creating our base panel. We will use for this the bounding box node. It is under geometry operations bounding box. Let's plug it in. As you can see, this box matches the size of our base geometry perfectly. We don't need the white dimension for now, so let's use the transform geometry nodes. And let's scale it in y to 0. To prevent overlapping vertices, we can use the merge by distance option. And this default settings tell Blender that every vertices that have distance between each other smaller or equal than this will be merged. And that will be it for our base geometry for single wood piece. Let's frame it by selecting and pressing Ctrl J, and we can rename it by selecting it and pressing F2 key. Let's call it base plane. And now we can scatter this plane along whole input geometry. And to do this, we need to create the line that will start from beginning to an end, resample it a few times, that we can later on use to scatter our base planes on it. And to do this, we'll use the node that is called attribute statistic. We can search it under attribute, and let's plug geometry to geometry. This node will allow us to analyze different fields, but it needs some attribute to analyze. So we would like to analyze the position. So let's first change the type from float to vector, because the position is a vector. This is violet input output. And let's search for position node. Plug it in. And now we can have different statistic from the position of our input geometry. For example, minimum maximum value in each direction. It's a pretty useful node. But what we want now is to create the line that will start in the minimum y direction and maximum y direction. So we will need the y minimum and maximum. And to do this, we can take the minimum and multiply it using a vector multiply node. Okay, default value are 0, so now this vector will be 0, which is not very useful. We only want the y value, which is x, y, z, which is middle value. So let's multiply it by 1, and thanks to that we will not changing this value. We can duplicate now this node by pressing Shift D and plug maximum. Let's create now our baseline. I will use for this curve line, not a mesh line, because with curve line we can easily change the density of points that will create this line. So let's add curve primitives and search for curve line. And we can plug the start point from our minimum and the end point for a maximum. And to preview it, we can just press Shift Alt. And as you can see, this curve perfectly matches the size of our input geometry, which is exactly what you wanted. Okay, so let's use now this curve line to scatter these planes. And to do this, we can use a node that is called instances on point. Thanks to this node, we can scatter this base geometry as instance on our curve line points. As you can see, when I plugged our curve line to points, we have two faces. And why there is no more? Because there is no more geometry on our curve line. It only contains 2 points, start point and end point. And to create more point, thanks to that this is curve, we can do it really easy by using node which is called resample curve. We can find it under operations and resample curve. Plug it between our curve line and points, and as you can see, now we can control the number of points. But even better, we can control just the distance between each point. By default it's set to 0.1 meter, but as you can see it's probably not the 0.1 meter because this grid is 1 meter in dimensions. And why is that? Because if we press N panel and search under item, the scale of our object is not set to 1. And to fix it, we can just play Ctrl A and scale. And now if it is set to 1 correctly, the distance is also correctly. Often in Blender, if we have some problem with modifiers or geometry nodes, it's often caused by issues with scale. So always remember to play Ctrl A scale if you scale object in object mode. Okay, now we have our scattered planes. So the next step will be Boolean it from our input geometry. But to prevent slow calculation in later on, we can temporarily disable the subdivision surface in viewport by pressing monitor icon. And thanks to that, the time of computation will be much quicker. We can actually preview the time of computation by turn on timing option. As you can see, it's not changed at all, but when we create our Boolean operation, it will have significant impact of our performance. So let's duplicate the input to our node group. And let's use node called Mesh Boolean. So Mesh, Operations, Mesh Boolean. Let's plug it in. As you can see, we have an error that still instances in input geometry are ignored. And that's because we didn't realize our instances, so this is still instance, which means we cannot edit it directly. We can only change the rotation, scale and things like that in instances, but we can't change geometry of each instance. And to fix it, we can use node that is called Realize Instances. Under Instances, Realize Instances. Okay, now we get rid of error. So let's plug our group input, our to mesh 2. As you can see, it do opposite now, so we need to switch inputs between each other. Okay, and now we have our Boolean, but as you can see it's not very visible in viewport what's going on. So to fix it, we can go to viewport shading setting, and under cavity option we can turn it on and change to world. As you can see, it's much more visible now. We can increase the contrast under settings, but keep in mind that this will slow down your viewport performance. So if you have trouble with viewport performance, you can turn off this option. If you see this little noise around here, you can always increase the amount of samples. Now we can easily see the individual panels. Okay, when I turn this option on, we can clearly see that there is some Boolean issue here. And to fix it, we can go back to geometry node and turn on this cavity option here too. And to fix it, we can enable self-intersection option and hold orange. It will increase the computation time, as you can see. but it will get rid of these issues. And now I will show you why we turn off the subdivision surface modifier, because now the computation time is something about 1/3 of a second. But if we turn off our subdivision surface, it will increase to probably a few seconds at least. As you can see, 7 seconds, which is really slow if you want to create some changes after Boolean. So we'll turn off it for now and work at the much simplified version. Okay, so the next step that we'll need to do is to create the thickness in our panels. And to do this, we can use the node that is called Extrude Mesh. We can find it under Mesh, Operations, Extrude Mesh. Let's plug it in and decrease the offset scale. And as you can see, we have a problem here, because all the panels except the first one is extruded in the right direction, and this is in the opposite direction. And to fix it, we can do it pretty easily. We can add the scale elements geometry node and plug it before everything. And if we increase the scale, we can fix it. And why is that? Because if we increase the scale of it, the points from the curve, the beginning points of the curve and the last point are never really used in our mesh boolean, because they are out of the object. So we can fix that issue like that. Maybe not the most clever solution, but it works, so it's pretty good. Okay, we can turn off the individual option because we don't need it. And then we have a problem that our geometry is not closed from this side. We have a hole. And to fix it, we can just use the join geometry node and plug the mesh boolean before our extrusion. And now it's closed. But this will generate two issues. The first one, if we turn on under viewport overlays the face orientation option, as you can see, we have some red faces, which is not good. And to fix it, we can use the flip faces geometry node. Okay, first problem solved. And the second one is overlays vertices. Because when we join this geometry to this geometry, as you can see, this vertex is present in both inputs to join. Okay, so to fix this overlapping geometry, we can use a simple node called merge by distance. We can find it under geometry, operations, merge by distance. Okay, and now we have fixed this geometry, and it works pretty nice. To preview the final result, we can turn on the subdivision surface modifier. And as you can see, it took 2 seconds, which is not bad. And this is our current result. If we enabled shade auto smooth before, we can turn on the smooth shading by adding set shade smooth node. Okay, so this is our result, and it looks pretty nice. And the last things that we can do is to create the random value for each individual element, because I would like to use it later on in shader. So to do this, we can use a node called store named attribute, and for the performance, let's turn off the subdivision surface, and let's plug store named attribute. Okay, now we need to choose a name for our attribute, and let's call it maybe random island. And to create a random value for each individual geometry, we can use node what is called Mesh Island. Let's plug the index into value. And to preview it, we can use Ctrl-Shift shortcut to plug it to our geometry and once again to index. As you can see, everything is white and one is black. And this is because in a viewport we can only see maximum value of 1, which is represented by color of 1. But the index it's not from 0 to 1, but is 0, 1, 2, 3, 4, 5, 6, 7. So this is why everything else except this 0 is displayed as white. And if we want a value from 0 to 1 actually, and to do it easily, you can use the node which is called white noise texture. And if we put it between index and input from our stored named attribute, we can preview it, and it will generate a random value from each individual element. Okay, let's delete viewer node. And now we will be able to access this value, this random island, in our shader editor. So let's turn on the subdivision surface and jump to shading. Okay, so to use this value that we created, we can use the attribute node. And let's copy and paste the name of our attribute. Now when I press Ctrl-Shift, we can use this attribute that we created. So I will show now example usage of it by using material of wood from Polyheaven. Okay, so I use my own wood material. And we can use this value in two ways. First, to randomize the color of each plate for each element. And to do this, we can use the hue saturation node. Let's plug the color into our input. Let's decrease the value and increase saturation. And as you can see, we have now randomness in the color. And second thing we need to do, let's duplicate it. And before our texture coordinate, let's add another mapping node. And let's multiply the color output by some sort of big number. And let's plug it into location. And now, as you can see, we have a different placing of our material. So this is two ways we can use this attribute to randomize the material for each element individually. And this is pretty flexible geometry nodes, because when I turn off the subdivision to have quicker results, we can now, for example, extrude it, scale it, maybe not that much, but extrude it again, scale it, maybe extrude this one, and again scale it. When I turn off the subdivision surface modifier now and give it a few seconds to calculate, it all works perfectly okay. Okay, so this will be it for this tutorial. Thank you so much for watching, see you again soon, and bye!